GLP-1 is a 31 amino acid peptide, which is a hormone, which is in the class of a glucoincretin hormone. That is, it stimulates glucose-dependent insulin secretion. And by that property is an effective treatment for type 2 diabetes, and has the advantage that it stimulates the pancreas to make its own insulin rather than having to give insulin shots exogenously by injections, which introduces an untoward possibility of lowering the blood sugar to dangerously low levels and causing illness and shock. Interest in glucagon was because glucagon has the opposite effect of insulin in that it raises blood sugar rather than lowering blood sugar like insulin does. So we felt it would be interesting, and we're curious to know how glucagon is made in cells so that we would have a basis for understanding how glucagon works in opposite to insulin. So at the time I set up my laboratory, the new technology of cloning genes had been developed by a group on the West Coast, and gene cloning and became a possibility. So I elected to use this technology to clone the gene for glucagon. And to do this, we used the anglerfish as a first model animal to clone this glucagon gene. And one of the reasons for doing this was at the time the NIH had called a moratorium on doing recombinant DNA studies in warm-blooded animals, and like humans and rats and mice. So, but the anglerfish had the advantage that the endocrine pancreas that makes hormones was a separate organ in the fish, whereas in mammals, the endocrine cells are scattered about in the exocrine pancreas, and it makes it another technologically difficult to isolate the endocrine cells. So we succeeded in cloning the gene for glucagon, and during the sequencing of the nucleic acid sequence and decoding of the sequence using the genetic triplet code, we found glucagon in the fish, which was very similar to mammalian glucagon, but on continued sequencing came across a second glucagon-related peptide. It wasn't glucagon, but was related to glucagon. And we called it glucagon-related peptide, GRP. And subsequently, the moratorium was lifted, and we went to the rat pancreas, and cloned the rat gene for glucagon, and found that it had the sequence homologous to GRP, which we called the name glucagon-like peptide, glucagon-like peptide 1. But there was yet another peptide in the mammalian pro-glucagon gene called GLP2. And it turned out that GLP1 was a glucoincretin that stimulated glucose-dependent insulin secretion, whereas glucagon-like peptide 2 was a growth factor for the intestinal epithelial cells. The two major milestones are for the treatment of type 2 diabetes and a management and treatment of obesity and obesity-related comorbidities. A new treatment area is that for cardiovascular diseases. There have been some really remarkable clinical studies showing that people who are taking GLP-1 receptor agonists who have cardiovascular diseases and obesity, but not diabetes, have about a 20% reduction in the risk of developing heart attacks and strokes, so-called the SELECT trial by Novo Nordisk. So this is a remarkable disease category that shows promise and effectiveness in ameliorating the events that are related to cardiovascular disease. Remarkably, as more and more people are taking GLP-1 agonists, receptor agonists, for the treatment of type 2 diabetes and obesity, they're finding that the drug is effective in several other ways. And one is in suppressing inflammation, and then the other is in neurologic diseases like Parkinson's disease and possibly even Alzheimer's disease. And there's a number of inflammatory disorders in which the drug appears to be effective, and that is, for example, diseases associated with increased inflammation, such as inflammatory bowel disease, psoriasis, and we call MASH, that's hepatic metabolic hepatic steatosis. You're talking about using GLP-1 receptor agonists for cosmetic reasons to lose a little weight so that you fit into a dress or something to look better. And I think that vanity is probably a reality, and but it's up to, I would say, a physician to approve of such use. And there's always a risk of some side effects of GLP-1, although so far after administration to literally millions of people now, the side effects have been not serious, but the time is still required to determine such side effects may arise. So I think it's probably not a good idea to use it strictly for cosmetic reasons, but I think it's a possibility and should be discussed with the physician in charge, which I should say parenthetically that people who are taking the GLP-1 should be doing so under the guidance of a physician and not doing it on their own.